So follow along with me on page 41, please, here. We're going to learn how to figure out the molar masses of ionic compounds and how to convert from moles to grams or numbers of molecules for ionic compounds. So hopefully this looks familiar to you. This is what we called in trimester 1 the roadmap. And again, this is how we convert between these three things. We can go in any direction up here. You'll notice the arrows are bidirectional, but the central concept is the mole. If we're talking about an element, all we have to do to figure out the molar mass of something is to look at the periodic table. But when we're talking about molecules, like ionic compounds, for instance, you can't just look at their mass on the periodic table because they are made of multiple elements. So we got to do some addition, which is really the only new thing that we're adding here. Okay, so the basic concept is if you are looking at a compound, an ionic compound like zinc nitrate, the way that you figure out its molar mass is to add up all the individual components. So zinc nitrate has zinc in it, it's got nitrogen in it, and it's got oxygen in it. And notice that it's got 3 oxygens per nitrate. Okay, so we have to account for all that. One important thing to go over here is the parentheses. So that's what we see up top. And this is a little bit like stuff that you've seen in algebra. For example, this algebra problem up here, you guys probably know that if you want to kind of simplify that, you distribute the 3 through here and apply it to everything. And you can simplify that expression into 12x plus 9y. It's similar in chemistry, just kind of on the other side. So we have this compound right here, which is nickel dichromate. And we need to figure out how many nickels, carbons, and oxygens there are per molecule. So the way that we do that is we've got to distribute this 3 through here. So we have 3 times 2 for carbon, which gives us 6 carbons. And then we have 3 times 4 for oxygen, which gives us 12 oxygens. And then we have 2 nickels here. So those are all the parts that we've got to add up when we determine the molar mass for that particular compound. We talked earlier today about hydrates. If you're dealing with a hydrate, then you also need to factor in the mass of water. Some people like to skip that. So in addition to adding up the copper, we're going to add up 2 times 3 is 6 oxygens. 2 times 1 is 2 nitrogens. But this is a trihydrate, so we've also got to multiply the mass of the 3 water molecules. So in this case, with a coefficient, it's going to distribute to the right. So we have 3 times 2 is 6 hydrogens. And we have 3 times 1 is 3 oxygens. And that's in addition to the 1 copper that we have. So when you calculate the mass, you're going to have to add all those up. So let's do our first example down here. It says to calculate the molar mass of zinc nitrate. So we need to, again, distribute the 2 through here. So we've got 2 times 3 is 6 oxygen molecules in this compound. We've got 2 times 1 is 2 nitrogens. And lastly, we have just 1 zinc. So in this column, we're going to put the mass from the periodic table for each of these elements. Zinc's is 65.38 grams. Nitrogen's is 14.007. And then oxygen is 15.999. Again, we got those numbers all from the periodic table. But we don't just have one of each of those, so we got to do a little multiplication here. So with zinc, I do have 1, so 1 times 65.38 gives me that number. 2 times 14.007 for nitrogen gives me this number, 28.014. And lastly, 6 times 15.999 gives me this number. And my final step is I need to add these three together. And when I do that, I'm going to get 189.388 in the calculator. Then I need to round that using my rules of significant figures to 189.39 grams. So we just figured out that 1 mole of zinc nitrate equals 189.39 grams. So I can use that now as a conversion factor, just like we have all year, to convert between grams, moles, and molecules of zinc nitrate. One thing that I want to say is we're not really going to emphasize significant figures from this point forward. So if your answer is close, we're not going to ding you points for rounding. However, when you're in Albert, it's going to ask you to round your answers in some case to the hundredths. So you need to be able to do that. You need to understand what the hundredths means, what the tenths means, and you need to be comfortable with rounding in general. Okay? So we have our conversion factor now. So let's do one of these conversion problems. The question here is, find the number of moles in 50 grams of zinc nitrate. So we're converting from grams to moles. So I put 50 grams in my starting spot. I put moles in my ending spot. Here is my conversion factor that I just figured out above. As we've done all year, I'm going to put my starting number and unit in this location. I'm going to multiply by my conversion factor right here. And I'm going to arrange the fractions so that I can cancel grams out. And then I simply plug the numbers in to the train tracks into my calculator. And remember, we times on top. In this case, that's 50 times 1, which is an unnecessary step, right? And we divide down. So basically, I've got 50 divided by 189.39, and your answer should be 0.264 moles. So 50 grams of zinc nitrate is equal to 0.264 moles. You guys have any questions about that? Okay. Good work on your practice problems. The next couple pages, 42 through 44, we're going to have a small quiz on this second half of the period on Monday. And that'll be our final quiz of this unit.